Hello, so today we're going to be talking about Newton's first and second law. So the first law is an object in motion tends to stay in motion and an object at rest tends to stay at rest. So unless there's going to be an outside force acting upon your object either moving or at rest, it's going to either stay moving at the same velocity or stay completely at rest. So whenever it's at rest, you're only having two forces acting upon it. So you're going to have your net force and your weight. Another key word for this part is also called inertia. It's also going to be a key part of the first law. Alright, so at constant velocity, you're going to have the same object in motion, so it's going to stay constant right now since there's no other forces acting upon it. But when you do have a force acting upon it, say you have one pushing from this side, your object is going to accelerate this way, F push. So whenever it is being pushed, it is accelerated to the right from whatever the outside force is. Alright, so it's second law. If a net external force acts on a body, the body accelerates. The direction of acceleration is the same as the direction of net force. The mass of the body times acceleration equals the net force. So basically what that means is F net is equal to mass times acceleration. And then your units for this is going to be kilograms times meters over seconds, which is going to equal to newtons. So your force is just newtons. Alright, so a practice problem. Let me see if you can see that. There you go. Sophie, whose mass is 48 kilograms, experiences a net force of 1,750 newtons at the bottom of a roller coaster loop during her school's physics trip to Six Flags. Determine her acceleration at this location. Alright, so it's the same as before. Force is equal to mass times acceleration. So your force was 1750 newtons is equal to 48 kilograms times acceleration. So you're trying to find your acceleration. You're going to equal that to 1,750 newtons over 48 kilograms. And when you divide this out, you're going to get around 36.458 meters per second squared, which is going to round to about 36 meters per second squared. So her acceleration at that bottom part of the loop is going to be 36 meters per second squared.